Welcome to this series of videos titled Draw with Ranga, and in this video let's look at 10 steps to a great developer. One of the most important things is I am restricting this down to developing great web applications, microservices and inside the cloud. I am not really experienced with mobile applications, so I will not get into the mobile world, but I would typically focus on the web, full stack, microservices and the cloud world. So that's where I would go deep into. And over here, one of the other warnings is that we are not really focused on programming, right? So programming is one of the most essential things to be a great developer. So you need to have great data structures, you need to understand algorithms, you need to be great at your fundamentals, right? So that's kind of a given. So you are expected to be really good at programming. Now, what more can you do to become a great developer? That's what the focus of this video is. Let's look at all the 10 top things that I think make a great developer. If you have any suggestions on what I missed, do not forget to comment and put your opinion down in the comments. So there you go. That's kind of the introduction, and let's get started with my 10 steps to be a great developer. The first and the most important thing about a developer is the fundamentals. What are the fundamentals of a programmer? We already touched upon one of the fundamentals of a great developer. That's you have to be a great programmer, right? So you should understand your language very well. So if you are using Java, Python, JavaScript, you need to be an expert at your language. If you are using Java, you need to understand what are the new features in Java 8, Java 9, and you should make the best use of all the features which are provided by your language. So the fundamentals of being a great programmer is understanding your language. So Java 8, let's say, is functional programming, right? So one of the most important features in Java 8 is functional programming, and you should know how to use functional programming. Java 9 brings in modularization. So you need to understand modularization. You should understand the release cycles of Java. Java changed how the release cycles are done in the recent for the recent version. So right now we have 6 bi-yearly releases. So we right now are at Java 13 and Java 14, right? So Java 14 is the next version which is expected. So if you look at, you need to understand all this stuff around the programming language that you are working with. So that's the fundamental. And the other fundamental is your business domain. You need to understand your business domain very well. You are a programmer. You are developing an application in a specific business area. You need to understand that really well. The third important skill as a programmer, which is very important, is debugging, solving problems. You should have the skills to be able to find out what's going wrong. You should be able to think and solve all the problems that are present. So that's the fundamentals. The fundamentals are basically that you need to understand your programming language very well. You need to understand your business domain very well, and you need to have great debugging skills. Now, let's get down to the second important factor according to me. The second important factor according to me is simple design. So, simple design. What do I mean by simple design? One of the most important aspects to be a great developer is to write maintainable code. Code is written once, but it's maintained for a lifetime. A typical developer spends 20 to 30% of his time in writing code, maybe even lesser, and 70% of the time in maintaining it. So in reading code. So it's very essential that your design is simple and your code is very easy to read. And one of the best ways to ensure that is to follow something called 4 principles of simple design. If you are not aware of 4 principles of simple design, I would recommend you to look at the description of this video. The 4 principles of simple design really help you in making your design simple and help you to write really easy and maintainable code. Typically, whenever we talk about design, people would confuse it with design patterns, right? I understand that design patterns are really important, but you might not want to use design patterns everywhere. The most important thing about a design pattern is to understand the context and then use it. You don't just introduce a design pattern because we know a design pattern. And for me, the most important thing about a design pattern is actually to understand the context and kind of understand the solution at a high level. You don't really need to understand the details in depth. If I see a problem, I should be able to find out, okay, maybe a prototype is a good thing to do in here. Maybe some other pattern is a good thing to do in here. That's kind of the thought process I have around design patterns. Once you identify that this is the right pattern, you can go and search the details on the internet. If you just do a Google for strategy pattern, observer pattern, or whatever pattern you would want to learn, you can get the details very easily. But the most important skill is to identify the context and identify this might be a good design pattern to use. So do not try to fit in all the design patterns, and try and have a high level design pattern overview. The other important part of your programming career, if you are doing Java or one of the object-oriented programming, is understand object-oriented programming in depth. So you need to make sure that you understand the solid principles. So if you don't know what the solid principles are, you can find a link in the description which will help you to learn the basics of solid principles. Solid principles help you to write good object-oriented code. The other part of simple design is to develop loosely coupled applications which are maintainable. The third aspect that I would want to touch upon is test-driven development. Oops, I am using a wrong color to do the box. So let's fix that. TDD, test-driven development. Why is it so important, right? Typical cycle that we would follow when we write code is first we write code and then we write the test. So we write the code, then we write the test. But what happens when you do test-driven development is you write the test first. So this is done first and coding is done next. What happens is you'd start thinking from the perspective of outside in. So you are looking at how can I write the test? And then you are looking at how to actually write the code for it. So you are actually getting an outside in perspective, especially when you are building APIs or things like that. An outside in perspective really is very important. And also we see that test-driven development, if you follow it stringently, you'd see that it improves the design as well. So when you follow test-driven development, you would see that you were able to easily adhere to the 4 principles of simple design. So test-driven development is all about actually following a simple cycle. Test, write a simple test which causes the code to fail, do the coding to get it working, and after that refactor the code to 4 principles of simple design. So write a test, get it working, then refactor. Write a test, get it working, refactor. Write a test, get it working, refactor. That's what test-driven development is all about. So choose the smallest bit of test that you can write the code to get the code working, the test working, and then refactor to make it adhere to the 4 principles of simple design. So that's kind of the test-driven development cycle which is followed. The fourth important factor that is very important for me is having a great attitude, right? You are a developer and you are writing code which would be maintained for a long period of time. One of the most important differences that I observed between great developers and good and not so good developers is the attitude to learn every day. They follow good people on Twitter. They keep up to date with technology. They know what's happening in the technology world, what languages are getting popular, what frameworks are getting popular, what architecture methodologies are getting popular, and they are ready to explore any new things whenever they get a chance to explore something. So keep learning every day. One of the best ways to keep learning every day is to work with very smart people, right? So work with people who are smarter than yourself, and that would be the best way to actually keep learning every day. And the other things I would recommend you to do is to look at your project and try and learn from it. Try and understand why specific choices were made. So we are talking about the ability to learn. So continuous learning. Actually, continuous learning is so important for me that I called my channel in 28 minutes. in 28 minutes is all about learning for half an hour every day. I was not able to get the domain in 30 minutes and had to settle for in 28 minutes, but I see that the top 5% of people in every career path or in every profession actually keep learning every day. And that's what differentiates them, and that's very, very important even as a great developer. So the attitude to learn is one of the most important things. The other thing is the attitude to keep improving. In developer terms, we call it the Boy Scout rule. So if you see there is an error somewhere, if you see that some code is not really good, you improve it. The Boy Scout rule is more like you go to a campground, and whenever you go to a campground, you leave it in a better shape than when you were when you first came down there. That's the Boy Scout rule. And you apply that to your code, to your design. So you keep identifying things to improve on, and you keep improving your application code, design, and architecture. That's what Boy Scout rule is all about. The other important thing about a great developer is questioning everything, asking why. To understand everything that happens in your project, you need to ask. If somebody says, okay, this is the choice we are making, you need to understand why. When A is chosen, why not B? Why not C? Why not D? So you need to understand that, and the attitude to question is also very, very important. It's a big part of making sure that you do continuous learning. So the fourth thing that we have looked at is great attitude. You'd want to learn every day. You would want to improve everything that you are working with every day. You would want to question everything. The next thing that we would be talking about is very, very simple. That's number 5. It's master your IDE, the integrated development environment that you use. If you're using Eclipse, IntelliJ, or you are using Visual Studio Code, be a master at it. Why is it important? It is very, very important because you are going to use it for a long time to come. And also, you use it for a long time every day. Typical developer would spend about 50 to 60% of his time on the IDE. So learn all the things that you can do to master your IDE. Learn all the shortcuts for your IDE. Try and do everything with your keyboard and try and understand how to do things in lesser number of steps with your IDE. So focus on your IDE, try and spend at least, if you are not a master at your IDE, this is one thing you can really start with to improve your productivity right away. Start mastering your IDE and you'll see that you'll really save hours and hours of your time over a long period of time. The sixth thing I would be talking about is architecture. You need to understand the architecture of the application and the surrounding applications. So your application might be part of a big enterprise, right? So in the enterprise, your application is not the only one which is running. So you need to understand the big picture architecture of how things are working. It's not sufficient if you understand your application. You need to understand what's the data coming in, what's the data coming out, what other applications are present in your enterprise, and where is your enterprise architecture heading. So that's very, very important. So you need to understand the frameworks, the tools, and all that stuff around the architecture that is being used in your project. And also you need to understand the architectures which are used outside your project as well. So which architectures are getting popular. For example, you need to understand the evolution, right? So we started with web applications, then we moved into REST API. Actually, before REST API was SOAP web services, service-oriented architecture. And after that, we moved into REST API. And after that, we moved into full stack applications, microservices, container orchestration, cloud. So it's very, very important to understand a high-level overview of everything that's happening in the enterprise world, in the architecture world. So you need to understand the frameworks, tools, methodologies, and all that stuff. Now, coming at number 7 is something which is actually part of the architecture, but if you are a back-end developer, it's very, very essential that you become a full stack developer. So a full stack developer is somebody who can develop a front end and a back end as well. So you can develop a REST API as well as you can build a front end application using JavaScript, probably ES6 or TypeScript or React uh, the language is JavaScript, ES6 and TypeScript are, ES6 is modern JavaScript, TypeScript is layer on top of JavaScript, which will help you to write even better JavaScript code. The popular frameworks to develop the front ends are Angular, React and Vue, and popular backends are probably built using Java, Python, or typically also built using Node.js. The reason I'm explicitly calling out full stack as something you would want to learn is because I think that with the device explosion, earlier there was just a laptop or a computer from where you would be able to access the application. Today you have mobile applications, smartphones, iPads, and today we are also talking about Internet of Things. So understanding the full stack architecture and building applications with it will give you a great heads up or great head start over other developers. So if you are not a full stack developer yet, then I would recommend you to actually check out full stack and learn full stack as well. The other important architecture trend comes at number 8. What is the trend? That's containerization. So today we are heading to a world where almost everything is containerized and also container orchestration. So we are talking about containers and container orchestration. That comes at number 8. What are the popular tools for containers and container orchestrations? The popular tool for building containers is Docker, and the popular orchestration tool is Kubernetes. So I recommend to learn container and container orchestration because we are heading to a world where we would really want to be platform independent and language independent. So if you have a Python application, if you have a Java application, if you have a Node application, you don't want to have different ways of deploying that. You'd want to have a single way of deploying that, and containers play a big role in that. Docker helps you to build a simple image for all the types of different languages. So irrespective of the language, you can build a Docker image, and after that you can hand it over to the container orchestration tool to deploy it and manage it. So Docker helps us to create easy, simple boxes. Whether it's a Java application, whether it's a Python application, you can create very, very simple boxes which can be taken and put it onto a ship. And who manages the ship? The ship is managed by the container orchestration tool, which is Kubernetes. In a microservice architecture, let's say I have 5 different microservices, 50 different microservices, or 500 different microservices. You don't want to manage them individually, and that's where container orchestration comes into picture. A container orchestrator provides a number of features around managing your instances. So you can have multiple instances of your microservices. So let's say I have 5 microservices. I can have instance A, B, C for one microservice. This microservice might just have one instance. This microservice might have 1,000 instances. So based on the load, the container orchestration can increase the number of instances, decrease the number of instances. If one of these instances goes down, it would also make sure that it's coming up. So it launches up another instance to make sure that you have the right number of instances to handle the load available. So it's fault tolerant, and also it provides a lot of features which are typically needed by microservices. It provides a service registry, it provides load balancing, and a wide variety of features. So Docker and Kubernetes are things I would recommend you to learn if you are not aware of them yet. The 9th thing that I would recommend you to learn is microservices and cloud. The microservices architecture is very, very popular these days, and the best place to deploy the microservices architecture onto is the cloud. So understanding why we need microservices, understanding what are the challenges with microservices architecture, understanding how you can actually deploy microservices to the cloud is a very, very important thing that you need to understand in today's world. If you go a few years back, all that we had were very, very large applications. We used to call these applications as monolith applications. These applications were very, very difficult to deploy. Like any release used to take 3 months, 6 months, 10 months, some places. So it used to take a long time. It's like giving birth to a new baby. So and slowly we switched over to the microservices architectures. Instead of building one large application, we would build a small number of services which talk to each other. The challenges associated with the microservices are that you'd want to be able to build these microservices very, very quickly. You'd want each of these microservices to be able to talk to the other ones in a dynamic environment, right? So if I'm talking about a microservice A, B might have 10 instances, A might just have 2 instances. And if I have a call going from A to B, I would want to load balance it between all the 10 available instances of the microservice B. So you'd need service registry, load balancing. You'd want to be able to manage the configuration for all these different microservices. So there are a number of challenges which are associated with all these microservices in the microservices architecture, and you need a lot of infrastructure support that is needed to support all this stuff. And in parallel with that was the evolution of cloud. So cloud is very, very useful because the load on the application is not very similar all the time. So if you talk about Amazon, it might have a lot of load during the Thanksgiving days or during the Black Friday. On the rest of the days, it might only have 25 to 30% of that load. If they procure all the infrastructure needed to support the peak load, then what would happen when there is no load at all? All that infrastructure is sitting idle, right? And cloud through dynamic auto provisioning. So you would be able to provision resources on demand. So on demand provisioning of resources is one of the most important reasons why cloud is becoming really, really popular. The other reasons is also that you'd be able to remove undifferentiated heavy lifting. So if you look at microservices, there is a lot of infrastructure support you would want. You would want a centralized configuration, you would want naming server, you would want an API gateway. So all these features cloud can provide for you. These features do not really differentiate you from your competitors, so it's better to use it from your cloud provider. And that's where cloud is really, really getting popular. Cloud also helps you in making sure that your applications are highly available, and also you can deploy it in multiple regions across the world. So because of all these reasons, microservices and cloud are becoming really, really popular, and I would think that in the next few years, it's all about cloud. So cloud is here to stay, and that's one of the most important skills to understand as a developer today. Actually, not just for developers, but I think it's very, very important for everybody in the tech world to understand what is cloud and what are the things that it can bring to an enterprise and to even a startup. Even a startup can really, really benefit from all the things that are provided by the cloud. So I would recommend you to actually pick up one of the cloud providers, AWS, GCP, or Azure, and I would recommend you to learn the cloud. The last and the most important thing that we would want to recommend to you to learn is DevOps. DevOps is something which is highly misunderstood. DevOps is actually a process thing. It's a mentality. I mean, it's something to do with how we think. For me, DevOps is all about having great coordination between the teams. So having everybody in the team responsible for everything. Typically, the thought process earlier was you have a development team, you have a testing team, you have an operations team. The development team is responsible for the development of the software, building in new features. The testing team is responsible for testing them, and the operations team is responsible for managing the production environments. And the operations team is actually responsible for maintaining the uptime of the production environments. So what happens in these kind of situations is the goals of a operations team are different from the goals of a development team. The goal of a development team is to push as many new features to production as possible. And the goal of an operations team is to actually maintain stability in production. And these are two conflicting goals. So that's where DevOps comes into picture, where we would start looking at everybody as a single team. So your goal as a team is to build new features in a stable way and release them to production. So you have a goal for the entire life cycle, and you do all the things that are needed to make this possible. Now, what are the important things that you need to do to make DevOps possible? One of the most important things is code quality. You need to write great code. So code quality should be awesome, right? So we already talked about 4 principles of simple design. We already talked about test-driven development. The important part of DevOps is to ensure that you have tools to automate the checking of code quality. Manual reviews, code reviews are very, very important. Manual code reviews are where you can check for naming of variables, whether the low-level design is good. But tools can also check certain parts of the code quality stuff. So using tools like Sonar and things like that and having them as part of your build lifecycle is very, very important. So understand the code quality tools which are present, which can check how the code can be checked. The other important part is doing the build of your code, right? So you'd want to understand how Maven works, how Gradle works, so how your code is being built. It's very important to understand all the tools around your build. The other important aspect is automation tests. If you look at the pyramid model, typically whenever we talk about automation tests, we talk about something called a pyramid model. At the bottom of the pyramid model is your unit tests. On top of it are your integration tests, and on top of it are the UI tests. So whenever we write tests with JUnit, whenever we write tests with Mockito, Spring Unit test, we are either writing a unit test for a single component, or we are combining the entire thing across multiple layers and we are writing an integration test. Spring Boot supports both those kind of tests very, very well. So if you are a Java developer, writing unit tests is kind of easy. I mean, I'm sure there are amazing frameworks available in the JavaScript world and the Python world, but it's very important that you write great unit tests and great integration tests. There are several frameworks which help you to write UI tests like Selenium. You have like a lot of automation around the UI area as well, so you can write automation tests for your UI as well. So it's very, very important that the tests around the code are automated as much as possible. The next important part of DevOps is IaaC, infrastructure as code. To be able to deploy your application, if you are using a microservices architecture, you'd want to be able to provision a number of resources and do the deployment. If you actually do all that stuff manually, then there is a high chance that you would make mistakes. That's where infrastructure as code tools like Chef, Puppet, Terraform, Ansible, all these come into picture. Even there are cloud specific infrastructure as code tools, CloudFormation in AWS, and a lot of other things in other cloud providers as well. So you'd want to automate the creation of your environment and deployment of your application into the environment as much as possible, and infrastructure as code helps you in the whole thing. The most important part of DevOps is actually continuous integration and continuous development. It's not sufficient if I have Sonar integrated into the build, if I have great project setup with the build. It's not sufficient if I have great automation tests written. The most important thing is all these things should be done continuously. Whenever a new piece of code is checked into your GitHub repository, all these checks should be done, and only then you get the immediate feedback that would enable you to fix the problem which is present. So in this last step, we talked about DevOps. We talked about the importance of code quality. We talked about the importance of automation testing. We talked about the importance of infrastructure as code, and we talked about continuous integration and continuous development, where you'd run all this stuff continuously. Whenever somebody commits a piece of code, you'd run all this stuff continuously, and whenever your business team says, yes, let's go for it, you'd use infrastructure as code to actually deploy it down. So as much as automation as possible, and keep this running a number of times. So we looked at the 10 steps which I think are important to be a great developer. We started with the fundamentals. We started with being a great programmer, understanding your business domain, having great debugging skills. We then went into simple design, the importance of why you should keep your design simple, the importance of maintaining your application for a long time, the importance of 4 principles of simple design. We talked about object-oriented principles and solid principles. After that, we got into the world of test-driven development, where we developed code in test, code, refactor cycles. After that, we talked about the attitude of a great developer. We said you have the attitude to learn every day. Continuous learning is very, very important. You have the attitude to improve whatever you see. You follow the Boy Scout rule. You have the attitude to question everything, to understand in depth about why a specific choice is made, why a specific framework is used, why a specific tool is used, why something is done a specific way. The next thing that we looked at was to master your IDE. Be great at whichever IDE you make use of, whether it's Eclipse, whether it's IntelliJ, whether it's Visual Studio Code or Sublime Text. Whichever IDE you use it, you have to be a master at it. The next thing we talked about was understanding the architecture, web application or full stack application or microservices or cloud. Understand the evolution of the architectures. That's very, very important. And after that, we looked at full stack and why it's important to be a full stack developer and what the advantages you would get if you are a full stack developer. The eighth thing that we looked at was container and container orchestration. Containers help make the packaging independent of the language. How you build the application is separated from how you deploy it. At the end of the build stage, you would have a similar deployable whether you have a Java application, a Python application or a Node application. And that would be the input to a container orchestration tool like Kubernetes, which would ensure that these applications which are running based on these containers are available all the time. You are always monitoring them. You can auto scale them, and all that kind of features are provided by the container orchestration tool, Kubernetes. The ninth thing that we looked at was the importance of microservices and the cloud. We are going to, like almost every enterprise today is moving towards a microservice architecture, and almost every enterprise today is also moving towards the cloud. Even banks and even government agencies are actually moving to the cloud. So it's imperative that as a great developer, you understand these two in depth. And the last thing which we looked at was one of the most important things, DevOps. Making sure that you check your code quality, making sure that you continuously build your code, making sure that you write great automation tests, making sure that you are able to automate the creation of the infrastructure and deployment of your application, making sure that you are able to actually do CI/CD, making sure that all these are working all the time. So these are the important elements of DevOps, and these are all the things which I really think are important to become a great developer. Now, you might be thinking, where do I go next? You can actually watch a lot of videos on our channel to learn about 4 principles of simple designs, design patterns, to understand how you can learn Eclipse, to understand full stack, to understand containers, orchestration, and also to understand microservices. And one of the frequently asked questions for us is, how do I become a full stack developer? How do I become a microservices developer? How do I learn the cloud? How do I become an expert on AWS? The amazing thing is we have learning paths built for each of these, and these learning paths contain what are the skills you would need, what is the learning path, how can you start, what can you do next, what can you do everything to achieve your goal, and also these learning paths contain videos and course recommendations with these things. You can find a link to these learning paths in the description of this particular video, and you can check out whichever learning path you would want. For example, the learning path 05 is the one which makes you an expert on AWS. So it has the recommended skills, it has the prerequisite skills, it has the recommended course path, and also it has recommended preview courses. These are free courses you can do, and also it has links to the other learning paths as well. We recommend you to make the best use of these learning paths to make sure that you stay ahead of the curve. Keep learning in 28 minutes. Until the next video, bye-bye.